us is that if you have a very large activation energy, if this EA is a very, very big number, that means that your rate constants will be very sensitive to temperature. So if this is really, really big, there's going to be a big change in your rate constants as temperature changes. And keep that in mind. We're going to come back to that later. So what do you think happens to the rate of an enzymatic reaction at liquid nitrogen temperatures? We looked at going from 37 degrees to 35. Liquid nitrogen is pretty cold. So not a whole lot happens at liquid nitrogen temperatures as far as enzymes go. And I'll just mention, so it slows way down, that this is a trick that I use in my research. So we have crystals of enzymes, and we can try to get structures in particular states by taking the crystals that have enzyme in it and starting a reaction and then dunking the crystals in liquid nitrogen to kind of stop it at a particular stage, and then you look at what the structure looks like. So that's one use. So we're going to also take a look at other reactions. We don't have any enzymes here, but some other things, and look at what happens when we get things to be very cold. So Dr. Taylor is pouring out some liquid nitrogen. And I don't know if you want to say what you're doing.
Yeah, actually, I don't actually have anything on this, so I think it's okay. All right, so what we're going to look at is a reaction that we can see pretty easily here. Have any of you used glow sticks before, maybe trick-or-treating or some other point? So basically, you may or may not know how they work. There's two compartments in glow sticks that have two different chemicals in them, and they're trade secrets, so we can't put them on the board. But basically what we have here is a reaction. A lot of reactions we know give off heat, or they give off infrared light. Here we have a reaction that gives off energy as visible light. So would you call this an endothermic or an exothermic reaction here? Yeah, so this is an exothermic reaction. So just as Professor Drennan was talking about with slowing down enzymatic reactions, we can think about if we can slow down this reaction. So we're just going to put it in the liquid nitrogen. And actually, do you think we could turn down the, can we turn the lights down if it can happen up there? All right. So keep an eye on this. We'll do several controls of different colors here. So see if an orange glow stick works the same. What we're looking to see is if we can slow down this reaction. What would we see if we slowed it down or even stopped it? Yeah, we're not going to see any more color. So are you starting to see color loss in this first reaction here? Yeah. So we'll try green. And yellow. So it looks like this first one might have stopped already. You see there's no color anymore here. What would you expect if this heated back up to room temperature? Yeah, so hopefully if you just keep your eye on this, we'll continue on with the lecturing because I don't know how long it will take for it to warm back up to room temperature. But keep an eye and we'll see if we get the temperature back high enough to see the glow again. And since we do have liquid nitrogen here, it's too hard to resist freezing a flower. This has nothing to do with kinetics. We can't even try that connection, but we will freeze the flower.
Some of you may have a hatred of flowers.
Okay,
so
she will try making it. Yeah, actually, good.
You should enjoy this.
Catharsis pre-exam.
So has anyone had liquid nitrogen applied to them? So it's used in doctors' offices. If you want a little something removed, perhaps, they put a little liquid nitrogen on and burn it off.
So this is good pre-med training for any of you. All right, I think we're pretty frozen here. So it looks the same, but as you can see, there are some different properties. Kind of like glass feeling at this point. So. All right, so I think that's all we can do.